Hello, my name is Kylie Chandler, and today I'm going to be teaching section 12.3 and similar triangles. Unlike last time we learned about congruent triangles with the same size and shape, but unlike congruent, similar triangles are similar if they have the same shape and not necessarily the same size. And so I'm going to be teaching about the different properties of similar triangles. So I gotta erase this. Okay. So the first one is the angle similarity property, but we can abbreviate it to just A. Okay. The angle similarity property states that two triangles with three congruent angles are similar by AAA. But it's AAA, but we just shorten it to AA. And so basically, you can draw two triangles. Oh, that is the wrong side. You cannot see that color. So we're gonna have a triangle like this. Gonna have the same shape, but a different size. Pretend those are the same shape. You have A, B, C, A, oh, nope. And we have D, E, F. So basically, like the property says, three congruent angles, two triangles with three congruent angles are similar by the AA. So basically, let's say A is 110 degrees, B 40-degree angle, and then C is 30. And then we have a triangle with not the same size, with the same shape, and D is 110, E is 40, and F is 30. So these triangles are similar because they have three congruent angles, A 110, D 110, B 40, E 40, and C 30, and F 30. So those triangles are similar. If it was a yes or no question, are these two triangles similar? It'd be yes, and by the AA similarity property. Erase that. And then we have side dash side dash side similarity property. This property states that if three sides of one triangle are proportional to the three sides of a second triangle, then the two triangles are similar. And that would look something like this. Again, we're gonna have you know what, I need to make that a little bit smaller and wider. So we're gonna have two triangles with the same shape, but not the same size. And this one's gonna be A, this one's gonna be B, this one's gonna be C, this one's gonna be D, E, F. 1, 2, 1, 2, 3. And then we have the same on this one. So this property works out if DE over AB equals EF over BC. So we have DE, AB. They both have the one tick mark. Same shape, different size. So it's DE over AB equals I really need to do that better. EF over BC. And then the last one's going to be DF over AC. Sure. DF AC. Oh, if all of that is true, then triangle ABC similar to triangle DEF. And that is the side by side by side similarity property. That's how we figure that out. Okay. And then the last property we're going to talk about is the side angle side property. And then, or the similarity property. So it's, I gotta erase this too. Side, angle, side. And so we have, and this property states that if in two triangles, the ratios of any two pairs of corresponding sides are equal and the included angles are congruent, then the two triangles are similar. So we're gonna have a triangle by like this, and then a slightly larger triangle. They don't look very similar. They don't look like they're the same shape. I promise that's what I was going for. So we're gonna label this one A, B, C. And this one, you guessed it, D, E, F. I could have spaced these out a little better. Sorry about that. So we're gonna have an angle here, an angle here. And then instead of all three sides having the tick marks, it's just gonna be 1, 1, 2. And then same on this one, 1, 1, 2. So on this one, DE over AB, those are correct. DE over AB equals EF over BC. And then if angle A equals angle D, then triangle ABC similar to triangle DEF by the side angle side. And a good way to remember this one is the initials are SAS, which is SAS. So this one's a little different. You can say it's like a little sassy, I guess, because it's like, no, not all three of mine are gonna be the same, only two, but they are still similar. I think that's a good way to remember that one, or that's kind of how I think of it in my head when I'm working them, if that helps. Don't know if it will. And for the end, to wrap it all up, I'm going to give a couple pairs of, like, there's gonna be two triangles and then another two triangles, and we're going to see if they are similar and by what property, now that it's all out of order. Okay, so we're going to do, let's do A, and then B. I'm trying to space these out good, sorry guys. A is going to look like this. Sorry about that. And then it's gonna look like that. Have A, B, C, O, P. Actually, we're just gonna do one example of this because we don't really have time for the second one. This one's gonna have an angle 60, and then 60, 30, 12, and 8. So we look at this and we see that angle O equals 180, because that's just the understood. 180 minus 60 minus 30 equals 90. So if we look back to the AA, it's the two triangles with 3 congruent angles are similar by the AAA similarity property. These all, like, if you subtract and figure it out like we just did, we see that all of the angles are the same, even though they're not all given to us. So we know that these are similar by the AA similarity property. And that's 12.3 similar triangles. Thank you.